So one of the extensions we'll do for this unit is simplifying radicals. So if we look at the square root of 63, for example, it's an irrational number. 63 is not a perfect square. And so if we were to type this in the calculator, remember we would get a decimal that never ends, never repeats. However, we can simplify it by looking for perfect square factors. So if I think about my factors of 63, 9 times 7 is 63, and the special thing about 9 is that it is a perfect square. So when we split 63 up, one of those factors has to be a perfect square. It's often helpful, I find, for students to write the perfect square factor first. So the square root of 63 would be equal to the square root of 9 times 7, and then we can split that up into the square root of 9 times the square root of 7. And because 9 is a perfect square, we can simplify the square root of 9, and the square root of 9 becomes 3. So we would have 3 times the square root of 7, or 3 root 7, as our final simplified answer. So again, you're looking for a factor of that radicand that is a perfect square. So for example, on number 2, we have the square root of 50. So I'm thinking of a factor of 50 that is also a perfect square. So we could split 50 into 25 times 2. So I'm going to go ahead and split those into two different radicals. So the square root of 25 times the square root of 2 would be equal to the square root of 50. And then we're simplifying. So again, I can simplify the square root of 25. The square root of 25 is 5, so I would get 5 times the square root of 2. We don't actually need that multiplication symbol there. Remember, when two things are written beside each other with no symbol, it's understood to be multiplication. So we could just put 5 root 2. 5 times the square root of 2 is how we could say that as well. 3, 4, and 5, similar thought process, only we see that there is a number in front of the radical. So we're going to walk through the same process. This would be like 5 times the square root of 18. We're going to split the square root of 18 up into two radicals. Again, a factor of 18 that is also a perfect square, so we could use 9, and the square root of 18 split into the square root of 9 times the square root of 2. So then when I'm simplifying, I could bring my 5 down. I can simplify the square root of 9. That becomes 3. And then I can't simplify the square root of 2, but I can bring it down. And so now I see a 5 times 3 out in front of the radical, which would be 15. And so my final answer would be 15 root 2. So if I try number 3, I'm going to bring the 3 down, times, I'm going to split the square root of 300 up into two factors. I'm looking for a perfect square that is also a factor of 300. So 100 comes to mind. Maybe you thought 25 or 4. You could use those, but you would have to keep simplifying. The square root of 100 times 3. So now we're going to keep simplifying. So we're going to bring down our 3. The square root of 100 is 10. And then we're going to bring down our square root of 3 that we can't simplify. Then I have 3 times 10 in front of the radical. That's 30. So my final answer would be 30 root 3. Pause the video and try number 5 on your own. And when you're finished, you can hit play again. For number 5, we have 4 times the square root of 45. I have 4 times, we're going to split the square root of 45 into the square root of 9 times the square root of 5. We're going to bring down our 4 times, we're going to simplify the square root of 9 to be 3 times, we're going to bring down the square root of 5 since we can't simplify that, and then outside in front of the radical is 4 times 3, which is 12, times the square root of 5, Number 4, I mentioned if you chose a different perfect square, you would have to keep simplifying. So here's one example of what I mean by that. If we were going to simplify the square root of 72, I could possibly choose 9. Maybe see the 9 as a factor of 72 because that would have been one of the multiplication facts that you might have learned. Some people might take this and split that into the square root of 9 times the square root of 8. We could simplify the square root of 9 and we get 3 root 8. However, we're not finished at that point because there is a perfect square factor hiding in the 8, right? So we could bring down our 3 and we could split 8 up. The perfect square that is a factor of 8 is 4, so we could split 8 into 4 times 2. And then we're simplifying, so we're going to bring down our 3. We can simplify the square root of 4, so we would get a 2 there. And then we have times the square root of 2. And then on the outside of the radical, we have 3 times 2, which is 6. So we get 6 root 2. Someone else might have said, oh, the square root of 72. I know a 4 goes into the square root of 72, so maybe someone else broke that into the square root of 4 times the square root of 18. We could simplify the square root of 4. We would get 2 times the square root of 18, but we wouldn't be finished because inside 18 there is a perfect square factor hiding out, so we could keep going. So 2 times, we can split the square root of 18 into the square root of 9 times the square root of 2. So we're going to bring down our 2. The square root of 9 simplifies to be 3 times the square root of 2. And then outside in front of the radical, we have 2 times 3, which would give us 6 root 2. So notice we come up with the same answer both times. We're just taking different paths to get there. And still, someone else might see the square root of 72, and they might say, oh, 36. So someone else might have split it into the square root of 36 times the square root of 2. And the square root of 36 is 6, so we would get 6 root 2. And notice they immediately arrived at the answer. So if you choose the largest perfect square factor, then you're going to go straight to the answer. If you choose a perfect square factor that isn't the largest perfect square factor, then it's going to take you multiple steps to get to that final simplified answer. So try a few on the practice sheet next.